to my YouTube channel. Today we will be designing a chat application. So this question has been asked in many of the top product-based companies including Walmart, Expedia, Amazon, Adobe, yeah, and so on. So let's get started with a chat application. So we'll be designing this problem where we'll be covering major concepts of system design also. So stay tuned. So let's come to functional, non-functional requirements. So functional requirements, we'll keep it simple, like there will be one-on-one chat and group chat options available. The messages may include text, images, and videos. Now coming to non-functional requirement, the system will be highly scalable. It should be available and message should be saved forever, so that user can come and see the history of their messages. Okay. So when we are talking about a chat application, what comes to the mind? The basics design is like this. There will be a sender of message and there will be a receiver. They will communicate through a server. So what the server will do, it will store message. It will send that message to the appropriate receiver. And if the receiver is not online, then it will hold the message until the receiver comes online. Okay, so the problem here is, since as you are a sender, you can send the message and tell the server that I want to send this message to particular receiver, and this is the message through an API call. Okay, now server has the message. Now, how server will tell the receiver that hey, this is your message? Because till now what we have covered is like client is calling, uh, hitting APIs and telling servers hit about the information, getting the required information. Anywhere we haven't seen that server is telling anything to the client. Okay, so yes, we can do this. There's many ways to do it. First, we'll start with the first way, which is polling. So what polling does is, every time at a particular interval, client will send one request to server. It will be an API call like, hey, is there any message for me? The server will reply no. So it will be a continuous call from client end to the server. There will be an API calls and it will be polled and on a regular interval. Here there is a message no, and if it has a message, it will send back. Okay, this is simple polling. Now there comes a long polling also. So long polling is like, client will send a request to server and wait for a particular period of time. So that in that particular period of time, if we get a message, the server will return. Otherwise, the request will time out. Okay. What the problem with these two approaches is, like, server is getting most of the time calls where it will tell no, there's no message. So that's additional traffic, additional load to the server, which we definitely don't want. It can create a bottleneck here. Okay, so the third way is WebSockets. So in WebSockets, what happens is, there is one HTTP handshake between client and server, where client tells his, I want to make a connection with you. As soon as this handshake happens, there is one bi-directional communication established between server and client. This is stateful. Stateful means that now the communication which will be happening between server and client will not have any kind of authentication, because authentication has already been done. Like, if what I mean by stateful and stateless is, so the connection, whenever we hit an API to server, we authenticate like this request is valid or not, the user which is hitting is authorized or not. All time authentication we do. So in that, those are requests as stateless. But in WebSockets, it is stateful, because we have already authenticated the connect client before. now we have established a stateful connection, bidirectional connection, where server can tell the client like, hey, this is your new message, and client can also tell the server, hey, I want to send this message. Okay. So in chat applications, we'll be using this WebSockets only. So what our design will look like is something like this. Okay, there will client, it will through HTTP call, normal HTTP call, it will communicate with authentication service, and this authentication service will be hitting this mapping service. So we will be having a mapping service where we will tell that we will be saving every user and chat server data. So now what we are doing is, there are, let's suppose, 10 people in our chat using our chat applications. So we'll assign different chat servers to different users. Okay. So this mapping server will hold the information of which user is assigned which chat service. And it will also be used for assigning the new chat service to users. Okay. So as soon as authentication is done, this mapping server has access of multiple chat applications. It assigns one chat server to our client and makes a WebSocket connection between them, and it also saves that data with them. Okay, that particular user assigned with chat server. And for databases, we are using NoSQL DB. Why NoSQL DB? Because we want our system to be highly available, and we want also these messages. It will be a lot of data which is will coming. We want to support different kind of text search also here. Text searches will be provided, and data will be also very huge. So it will be very easy to maintain in a NoSQL DB. Plus, we don't want anything. We don't want that consistency thing here. We want availability over consistency here. So that is why we'll be using NoSQL DB. Okay. Now, how our chat will happen? Let's suppose there's two client A and client B. Okay, client A has been assigned chat server 1 and client B has assigned chat server 2. So as soon as client want to send some message to client B, so client A will send a message to chat server 1 and tell, I want to send it to client B. Chat server 1 will communicate with mapping service and want to know that which server is being listened by client B. So as soon as it gets the information, it sends that message to a chat server 2, and this chat server 2 will send this message to client B. Okay, so this is how this message will happen. Before sending that message to chat server, we will save that message in a NoSQL DB. So in a NoSQL DB, how the DB will look like? So there are two type of tables which we'll be having for one-on-one message and for group messages. So for one-on-one, we will be having one message ID from user ID to user ID, and what is the message content and when it was sent. Okay, so we have just created that date. Now for scaling this NoSQL DB, what we can do is we can partition this uh, data based on user ID, from user and to user ID. So we can have this as a key and partition this data. And this for sort for like suppose there's two people sending message same particular time. So how you will be showing them in the sorted order in the chat history. For that, we can use created ID, but there is one more way. Like we can use a message ID column for that. This message ID will be auto-generated. We can use it like auto-generated IDs, and we don't need a global auto ID generator, because we need one local ID generator within that partition. So any ID generator within that partition will help here. So we'll be adding that message ID here from ID generator of that particular partition, and from into the partition keys and content we have the text and messages. For images and videos, what we can do is we can take help of some object storage like Google History, where we can upload that data and save that link with our content. Okay, same with group messages. Here, group ID will be a partition key, and we'll be having this data like of which user send this message, what the content. Now all the other information like users information, like group information, how many members are there in that group, that will not be part of chat service. That will be part of different services. Like here we have authentication service. Similarly, we can have one group service. We take care of all the groups and everything, creation of group, deletion, everything. And we one more service like user service, where we will be having data of uh, uh, user's profile like name, ID, photo, and everything. So we can have multiple services, and we'll be creating microservice architecture here. So that will be taken care of that, but the message part will be stored in this message only, in group message. So the chat server will be responsible for this group message. For the different services like user service and for group service, we can use basic SQL DB because their data won't be that much, and it will be we will be needing some type of consistency there. So we can use SQL DB here, but in chat service we will be using no SQL DB because they will use lots of amount of data we will be storing here, and we will also be doing text based search. So no SQL DB will be more helpful here. Also, if we want to add new keys in this, so NoSQL DB doesn't have any defined structure, so we can add new keys as well based on our requirement. Okay. Now comes one case where we will be sending one message. Client A want to send message client B, but client B is offline. Then what we'll do? So we'll be having one queue for every client. So as soon as chat server one sees that there is no server assigned to, so when you will be offline, there will be no server assigned to you. So as soon as no server is assigned to chat server for that client, what we'll do is we will be sending that pushing that message in a queue. As soon as client comes up and it is assigned a server, I mean that a client is online, he is assigned a server. So what we will do is we will be pulling all the messages from its queue. So client's B queue is, we will pull all the messages from the queue and send to the client. Also, we will send this message to notification service, where notification service can do push notification. Okay. This is what offline online behavior looks like. Now comes to the situation where we will be, let's suppose we have to show that client is online on offline. Okay, so for that, what we can do now, you can say that we are saving data of like user ID and chat server. So we can tell like if a chat server is assigned to a particular user, that means that user is online. Otherwise, that means he's not online. But this is not the correct way uh, to tell the user. Like it can happen that there is some issue with chat servers not getting assigned, but that user is online. Uh, so we cannot tell him like in every second or 2 second like online, offline, online, offline. If there's any uh, uh, network lag or there's internet issue, we cannot tell him. So what we can do is we can have one perseverance service. What it will do is that client will hit this perseverance service to know that which client B is online or not. What it does is this client will always send a particular heartbeat to the server, like, hey, I am online, after every few seconds. Hey, I am online. Hey, I am online. If it doesn't send any heartbeat after a particular period of time, like in a gap of X interval, maybe 30 seconds or 1 minute, then that perseverance server will mark that client as offline. Okay, that this can be done through cron jobs also. Uh, okay, and so like this, we get to know that yes, that user is online or not. So that's it. I think we have covered everything, starting with online, offline behavior, group chatting, one-on-one messaging. We have covered all the topics here. We got to learn about polling, long polling, as well as WebSockets. So yeah, thank you so much, guys. Uh, let's see you in next video. Till then, do like this video and comment if any of the design video you want to see. That's it. Thank you.